AI app builders are currently deploying multi-role operating systems. The Cohandy OS is a platform built entirely through AI generation. Because it serves both minors and mentors, the system requires rigid role-based access and youth safety protocols. Cohandy coordinates stewardship missions across specific city boroughs and connects them to international diaspora regions. Managing these resources across thousands of miles requires extreme data precision. This scale of software development differs from the common approach of using natural language to build simple tools. Deploying a system with multiple user permissions and complex data tracking requires abandoning conversational requests and adopting a strict declarative systems architecture. Before a large language model can render a single user interface screen, it requires a rigid boundary of rules to dictate how information flows. This split screen shows the difference: traditional code on the left and the system prompt for Cohandy on the right. Flowery language is stripped away in favor of explicit data schemas. Without these strict data structures in place, AI builders often hallucinate relationships. Tables cross-contaminate, and logic flows break under the weight of real users. The prompt acts as the delivery mechanism for the data model. In this environment, the software requires these explicit relationships to remain functional. This entity relationship diagram shows the Cohandy prompt's core tables. Note the specific connector between the participants and households tables. This relational link structurally ties parents to youth teams, enforcing oversight mathematically. The role pathways table provides the foundation for strict role-based access control. Rigorous database design is the only way to guarantee safety and consistency in AI-generated applications. Accessing the system requires a deterministic entry point. Cohandy calls this the gatehouse, a universal onboarding engine. The gatehouse captures initial user data and assigns a specific role pathway, like skilled worker. Once tagged with a role, the gatehouse funnels the user into an isolated UI dashboard, preventing any crossover. During routing, it captures critical consent flags, prepping the environment for automated logic. The gatehouse translates operational policies, like ceremonial onboarding, into strict software pathways. Executing continuous background logic, like verifying evidence or sending alerts, is challenging without traditional API calls. The solution is the events table, acting as the OS's central message broker. A base 44 superagent is an always-on AI worker, listening for specific database events. When the gatehouse writes an event, it wakes the superagent to execute tasks and log its action. When a youth completes a mission by uploading a photo, it creates a new evidence logs row. The evidence superagent intercepts this row, runs an AI safety classification, and updates the status. By isolating AI agents in a trigger action loop and logging everything, the system maintains integrity. Scaling live AI software risks corrupting the existing relational schema when adding entirely new platform features. Developers use a superagent-only expansion prompt to add massive features without touching the core tables, appending logic in a modular way. This method deployed the Diaspora Pathways module, linking urban youth missions to international origin regions. Panning across this Harlem street corner, we see the localized, community-level context of missions based in U.S. hubs. Now, zooming into the streets of Accra, we see the cross-oceanic scale the software must handle, connecting environments. Appending a diaspora tag triggers cross-regional superagent logic without breaking the local Harlem-based stewardship flows. Modular prompting allows an AI-native operating system to scale geographically while protecting foundational logic. This is the complete architectural stack. Relational tables support the events layer, feeding orbiting superagents that present UI dashboards. A mission completion hits the database, ripples through events, wakes a superagent, and triggers a ceremony script in the UI. Complex organizational culture, like Cohandy's youth progression, is effectively reduced to explicit, event-driven data structures. In the era of AI app generation, code syntax is commoditized. The only required developer skill is rigorous, declarative systems architecture.